Good day, everyone. Is this working? I always have to test to see if it's working. I think it's working. Every time I try to go live on here, it either can't find my webcam or it says it's busy or just it's always having to fight with the computer and the microphone. It's so low. It seems I almost have to scream in this thing. Maybe now it's going to be better. Test, test, 1, 2. I think that's better. All right, so eventually, if I can figure out how to go live without all this trouble all the time here. Check 1, 2, I think that's my mic. I see the green going up and down, so it must be working. So an update on things for today. Quite pleased with the power cells. For those who haven't been following me, this is going on a little past 3 weeks on some of these cells actually. And this one here is actually over 3 weeks old, and it was done with the solid state electrolyte mix, the PEG, and the copper oxide. That seems to really be helping it out. And all the various ones, as I've been demonstrating in the last few weeks, there are some, they all have slightly different compositions, and I'm testing for the best, you see. And the ones that are surprisingly working very well are the cement cells, like these ones here. They've been like well over a week dry now, and that's pretty cool. Same, I use equal parts of cement, copper oxide powder, and the PEG, few drops of water, just enough to make it into a cement-like paste, and let that dry. That's working very well. But this one here is one of the best, 1.4 volts, another cement cell. Just the foil and the copper, an alternative to the carbon felt. And that's actually the one of the strongest voltage-wise. A few of them are conditioned as electrodes, working very well too. This one's another one that gets over 1 volt, which I additionally conditioned as an electrode. So, and here's another cement. I tested, different parts to see if that made a difference. This one's still working well. Just oversized, actually, for what I had to do. But in some of the tests, I wanted to see if the electrolyte mix did a difference, how the volume of it, basically, per cell. And basically wasting it. You can have the same thing with a very small cell, like this one here is a very, very thin, as thin as I could make it. Works fine. So, in the background, I don't bother making daily videos about this, like pre-recorded and showing individual readings, unless there's something drastic. I think I mentioned this in one of the last few videos on the live session. The ones with just the PEG, some of the few earlier ones, especially the ones I didn't condition as electrodes, shortly after 2 weeks, I noticed a slight drop of voltage, maybe 0.6 instead of 0.1. And the ones with the copper oxide didn't exhibit that behavior. They're still showing the original volts that showed up the next day. They dried up. So that's interesting there. I'm still trying, good ideas, but still trying to figure out what the copper oxide is doing. And it seems to be doing the same thing with the cement mix. Now, personally, I like the cement mix because what it does is, look how it makes the cell a lot harder, right? It doesn't want to crack on itself because it's like a ceramic. As in, just with the PEG, it's more like a salt, very brittle kind of crystal, right? So things to consider basically down the road, and they'll have their quote unquote benefits. Um, Purely electret speaking, it's best in my experiments to stick with the peg and then condition them as electrets. That seems to be the best. So just little details here and there, you know, not quite enough to make a video just dedicated to that. So that's why, you know, it would be like 30-second updates basically. So the batteries I just made are rechargeable. That's cool. Yeah, I'd like to experiment with rechargeable battery composition some days, but obviously you get more current if you're going to recharge them. Uh, I like the electrostatic potential of these, actually. That's what fascinates me because they don't require an initial charge, and you can pulse them in capacitors and they come right back up. So that's what's fascinating. It's basically like an electrostatic version of a battery. You get a few milliamps out of them. You can short them out all you want and they come right back. No heating, no melting, no kind of negative issues. So, you know, normal batteries don't really work that way for obvious reasons, electrochemical and whatnot, reactions that we depend on. But I like this solid state electrolyte stuff for the electrostatic potentials of the two plates, basically. I think the copper oxide is what facilitates the electron flow, potentially, maybe. Because once they're completely dry, you know, it's no longer a wet cell, minus the moisture and the humidity, of course. Can't really, and any other electronics would be there anyways, so. Without adding more to the mix, so yeah, what I'm doing is I've got all these Triacs here that I got, like 5 of them, I believe. I tested these a while back because I wanted to build cap dumps, and for some reason they were all showing up as shorted out. And that was on another meter that eventually went bonkers that I threw out, but perhaps it was bonkers before, you know. So I figured, what are the odds that they're going to send me 5 new Triacs that are all shorted out? So I downloaded the spec sheet again for it, and I'm taking a second look. I don't know if everyone can see that, but this is the Triac that I have here, 800 volts and 600 volts, 25 amps. It's the BTA24, the one that I have here. And I've got the meter hooked up here and just making sure that to one of them, I want to make sure that they're not shorting out. I think they're not, because this meter here is not giving me the beep. So that's a good sign. So here's a schematic of an earlier project of mine. So those who say I never make schematics, so I'm going to follow that basically without the high voltage module. And I want to use my cells instead and dump the cap with the SCR. And I don't want to do it at 90 volts, obviously, so I'm going to have to modify the circuit a little bit. I'm probably just going to add a few diodes, regular diodes in series to take advantage of the forward loss, something around 0.2 of a volt, get it up to about maybe 1 volt so that it'll maybe a little 1.5 volts. So at 2 volts, the capacitor will trigger a dump because I don't have a million of these cells to put in series, right? So a couple cells, fill a short cap, maybe with 10 UF, dump it in a coil, and we'll take it from there. So that's the big plan of the evening, testing some SCRs, and hopefully I won't need 90-volt neons to trigger them, because from the specification, where I put that, I don't think I printed that page, but the gate trigger was pretty low, like starts at 0.2 of a volt, something like that. But I need to go a little higher than that. I'd like to trigger it at 2 volts. When the capacitor reaches 2, short it out into a transformer of sorts. Put all the cells in that, sequence them out all one after the other, so you get several clicks a second. I've got an idea in my mind of what to do with that to like amplify. Nothing that I've never talked about. It's all in my earlier videos, but send it back to the front bus. Who cares of the losses of bringing the potential up if these things can self-regauge, so that whatever it is that comes back through the next cycle is all that much more, plus whatever it has for the next pulse. So you always end up ramping it up. Granted, as long as I don't load it, but I want to load it, that's the point. You want to create amplification from natural mechanisms. And I always know cap dumps is a way to convert that pure potential to amps a second discharges. So if you can sequence it all, very interesting effects. I think John Hutchinson had something like that with his cells. He drew a bunch of cells, pulsed them in transformers, and sent it back, created that feedback loop. And if you don't load them, they'll overload on their own, really, because they'll just keep self. It's not like a normal battery, right? Where after that joule of energy makes the cycle, it's going to be that joule plus the losses. So the battery is going to have to put in that extra 20-some% for the next cycle, and on and on. So eventually the battery the VI curve just goes down until your cap dump would no longer have enough to trigger. But if the battery would be able to, by the next cycle, be able to bring its potential and current pulse back to the last one without that loss, then it's a whole different story. So granted, it's electrostatic, granted, it's only a milliamp or two, but when you start combining these into cap dumps and messing around with the potentials, this is where it gets interesting. So get a few watts out of it, maybe without needing maybe 20,000 cells. So kind of maybe shortcutting through it, using our Bedini and alike mechanisms, a little Tom Burden asymmetrical regauging, keeping that loop open. Let the system regauge for the next pulse, send that joule of energy back to the front bus, and repeat the cycle. So that's what I want to do down the line with all of this, and I'm eventually gonna make perfectly symmetrical cells for that. So I'm very pleased because it's been like 3 weeks or more now, and the cells then flunk out. So that's a very good sign, and no signs of corrosion, no weird green tint coming in through the solid state electrolyte, that even maybe moisture could, how copper can change color after a while. None of that going on. So that's a good sign, very good sign, because all I care about is electrostatic potentials. You have to find two dissimilar elements at the megavolt electron mega electron volts. And that creates your electrostatic potential difference, and that's your displacement, which creates your voltage. Can't do much with that, but we can sure charge capacitors. And people really underestimate what a cap dump can do. It's not magic, it's just being clever and not wasting the energy that's already there. I mean, why do we have to waste all the energy, right? Yeah, people totally underestimate electrostatic. Even the electrostatic at high potential, it gets even more interesting because then you can introduce the one wire system. Put another plate in there, the AV diode plug. Don't close that loop. Use the electrostatic as a trigger even against ground, and you've got a near continuous displacement current just out of that. That really ends up, man, oh man, the calculations of the Poynting vector. When you start getting into the 100,000 volts and more, you're getting in the 100-watt range of potential that's in a expressed as a field strength per meter squared. So you got to build reflectors and antennas and that sort of thing to capture that. But when you do, at least you got what your theoretical limit would be, at least. So even if you end up getting, my point was I loosely was getting like 7 watts in here out of an experiment. It's like, even if it's not efficient because I'm just inside here, it's that 7 watts is that much more coming in. 40 MA in, 7 watts out. I mean, but yeah, you could always upscale, you could always enhance. There's really no limits with all this stuff, whether you use magnetics, circuitry, mechanics, natural systems, you combine them all. It's so fascinating, and as long as you got the resources, the mind power, a bit of will, and trial and error, know a bit of what's going on, you could really take this. Look how Bedini did. He was really serious as a hobby. I mean, not that it powered the world, but a couple 100 watts if you're lucky, maybe. But it was the point, right? And that's what I never got about Bedini is like, he had like his the chromy motor and that. So what if the brushes go out after running them for a year or something? That's a pretty, as a kit, whatever, that would be pretty fascinating. It's relatively simple, right? You don't, you just run it. That's what people are kind of looking for sometimes. Same thing with the first thing you did. I think it was in the 80s with the 2 motors. That seems to be like much more simple methods and more output than doing the whole Bedin. You have to look at it at the financial part of it too and the practicality of it. It's really cool the way he did it. It's a whole different mechanism. But because I think Bedini really wanted to show people, and the Bedini wheel is a very good way to conceptualize it all, right? Because you see Bigot moving, but it doesn't have to be that way. And I think his earlier devices were much more efficient. If you're looking at the raw, I'm looking at this thing that needs 100 watts, and he says it gives you like 80 extra, so it's like 108. A lot of people would be happy with that in a can or something. So why overly complicate things? I mean, unless it's scientific, I get that. I want to explore, I want to try things, but he was serious. He got patents and he tried to commercialize that. Maybe that's where he went wrong. As soon as you try to do that with this kind of stuff, then you have your quote unquote secrets, and then people don't believe you because you're not giving them the full picture. And then it goes into the conspiracy category, right? I like to be open, folks, as much as I can, anyways, as long as I'm safe and it's not gonna, physical harm and that kind of thing. Everything I can, right? Got to be open, especially in this field. If you leave something back, it could be the most important thing. So how are the comments doing here? Took 5 minutes to recharge. That's not bad at all. If that's all it takes. Thanks for always sharing. No problem. I do the best I can. I do the best I can. Hasn't been that interesting lately because I've been focused on these power cells because, I've always lectured about the electrostatic potentials without actually, um, showing people what that means. And this is a good way of doing it. For now, without having the 1,000 volts and kilovolts generators, I want to do that down the line. But one thing at a time here. Also want to experiment with anti-gravity. I want to experiment with transmutation. I want to experiment with a little bit of space and time, scalar waves, and I did all of that. I was doing pretty good. Lost half my stuff, my equipment. Some of it was all well, technically not my equipment, but friends that were letting me use stuff. Some of it was surplus from NASA, still with the NASA calibrated stickers from 2005 on the stuff. So that was great. Man, some basic stuff, like a curve tracer. I missed that. Good for figuring out if certain rocks and whatnot can self-oscillate if you diode like P junctions, that sort of thing. Even testing that feature in semiconductors that are not usually used for that, but you have a bright idea, you want to. Bedini always did that, right? Use things that are a little bit out of range, but if it works. Bob Greener's work recently. I have to just the old stuff. There's so much, Oh my goodness. I got to catch up on that. But the thing is, I'm focused on because that's what people like right now is the alternative energy research. So with the little funds I have, that's where it's mostly going. But life is always cycles, right? It's ups and downs. And whenever I get that up again, I'm gonna start buying some real pro equipment for those more advanced quantum physics and space and all that, because there's problems with mixing these waves, and it's all security. It's you need emergency shutoffs, and it can't just be regular emergency shutoffs. It has to be like. What if you're running like big coils and motors, and when you do an emergency shutoff, you get an inductive kickback? Well, you need to have like something in the emergency shutoff that shunts that to ground so your circuitry doesn't go kaboom, right? So it's all that, and that's all commercial, that's all industrial. I know that, but then you got to bolt all that to real cases. But yeah, I mean, one day when I can split my resources, I will definitely get into all of that again, hopefully on my own, without the craziness of Timmins police. That was a bad experience. They were telling me, well, we don't know what the equipment is. It's not our job to find out what the equipment is. As long as it looks suspicious to us, that's all we need. So we're getting a warrant here, and we'll let the judge figure it out. We did our job. Yeah, I have a ham radio license. I have the authority to operate a radio station right here with all of this equipment. It's not my fault you're too stupid to know what this is. But that was the start of the end for that. I mean, at least I didn't have to go to jail because I had my lawyer friend that I called on the spot to tell them, not only will you be fired, but your whole force will be featured on front page of every Canadian press for this thing, ham operator being thrown to jail for the weekend because the cop didn't know what all the equipment was. Yeah. But that's just to show you the mentality I'm in here, with the people around me and all that. So you have to be careful, unfortunately. So that's that, right? I guess, I don't know. Timmins is so awful. They're like a little mafia there. I've never seen anything like it. I lived in Iroquois Falls. I live in Cochrane now. No problems with the people here. But Timmins is like crazy. They're not even 40. They used to be 40 some thousand. They're not that anymore, but it's like they think they're in New York or something. In the middle of nowhere in northern Ontario. Nobody knows but people who live there, but they think that the whole world revolves around them. So yeah, as you can tell, Timmins was a bad experience for me. I think I lived there for 3 or 4 years and came back here to Cochrane. Very snoopy people. I couldn't even go outside with my radio and take readings with my camera and explain what it was without someone calling the cops and telling them that it was actually me spying on them, and they felt uncomfortable because they had a bedroom window open or something. And meanwhile, I'm taking readings of a field strength, a video, and I'm documenting and saying out loud, okay, 40% here, and here's my antenna, and here's my roof, and here's the coil over here. Meanwhile, the neighbors are calling the cops again. They were at my place. Freaking, it was getting really annoying. So it was becoming harassment, really. And being on the system, you can't take them to court or do anything about it. So they got you by the quote unquote balls. But that's just Timmins police. They're their own little force in the city in the middle of nowhere. And then you have the OPP, which is Ontario Provincial Police, which is, I would say a much more civilized force because they're provincial, you can't get away with so much more oversight and transparency, I should see, because there's police boards and all that kind of thing. But a little police force like that in the middle of nowhere in the city, boy, oh boy, did I learn some lessons there. Here I am talking and talking. I'm not even testing my SCRs just to show you, right, what kind of some days you get like, ugh. But I'm doing good, happy with the cells. I know what I want to do with them. Takes time to accumulate the money and the resources and putting everything together. Especially sometimes it's not even about the money, like you find something for $20 on eBay that would work, but it's like $100 shipping because you're in northern Canada, and it takes 3 weeks to get here. So that's really a piss off and a big dent in a lot of my research. Um, like basic stuff you'd think, that anyone in the city could get that I can't find here. So I got to order it online. And they get you on shipping, they get you on import fees. It's $25 import fee. That's BS because that's the UPS people that charges that as a fee of their courtesy on top of the customs and the tax. So then you end up like, $60 a fee on top of that, and your item was like $20 or less. So you gotta really have to think, right? Do I really, really need this? Is this the only way I can get it? Because everything I buy online, no matter what, is over $100 by the time it's done and over with. And I gotta wait like 3 weeks for it to get here. Hello, everyone. Just I'm reading the comments, some people just coming in. Yeah, for the quantum stuff, it's high potential, high energetic, high pressure. It could be DC fields, static fields. No, electrodes are good for that, but we're on the super side. You need to switch heavy current really, really rapidly, and you need to phase the waves, modulate various frequencies. This is just very, very generally speaking here. Scalar wave, longitudinal with transverse waves, a lot of the Tesla interferometry stuff. Um, yeah, but this stuff is not, zero current stuff. This is, you really, for some of these reactions, you really, really, like something I want to try. I don't even have the power requirement here in the apartment to do the experiment. So I have to literally charge like a few 12-volt batteries, run my own inverter on there on its own isolated power supply, and I have a burst of maybe 3 minutes to do the experiment. But at least with that, I get more power than what I can get out of the mains. So yeah, if you're going to get into like the transmutation and all that kind of stuff, you need short bursts, but it depends on the effect you're looking for, right? Some things don't need that. If you're just looking for like quantum tunneling, quantum entanglement, you can get away with that kind of stuff for almost as long as there's any kind of resonant um, vibration of whatever can trigger these conditions. So yeah, it's a big domain. It's a big field. You know, it's all related, but it's somewhat, they have their specialty points, right? Well, the scalar potential is pure voltage in the sense of that, but we also talk about the scalar wave as the byproduct of the cancellation of a field at 180 degrees, and that creates the scalar wave, which is the sum zero field, essentially, making it really, really simplified here. Tesla was the pioneer of all of that. The faster than the speed of light waves. That's what that is. Because the energy can be destroyed, right? Okay, you're canceling that part of it, but it just appears as something else instead. You can only convert it. You can't actually kill it. And card just came in. The correlate. I guess you guys are all having conversations with yourselves because I'm not making but that's okay. As long as we're all here and that's important. We're all on this more or less on the same page with all of this stuff. So where was I? Yeah, I was testing these SCRs, which I'm going to do right now. One more time to make sure there's no short here. So that's fine because that's the same pin. I wanted that. So all of that's great. That seems to be working. So I guess my old meter was really flonkers because I figured, these can't be all, well, possibly, but. So next step is I'm going to find a capacitor to charge, a small capacitor, and I want to trigger it to discharge at around 2 volts. So I think I'm just going to use a bunch of regular diodes and with the forward voltage loss until um, I guess when the SCR reaches around zero point 0.2 or so, it'll trigger the dump. That's the plan, but the problem is things don't always go to plan. And what I hate is, I don't know, maybe people know of a better one, but most of the circuit sims I tried, they all suck at simulating all of this kind of stuff, for a capacitor to charge, the time it takes. I guess because it doesn't take account, current, voltage source, and all of that. But it's difficult to test in the simulator, so you got to really try on your own and see what works and what doesn't. Especially with all those oscillators with the single transistors and the coils, and such flonky behaviors with the simulators, especially when you're trying to tell it to bring the inductive kickback and using the AV diode plug and all that. It just doesn't know what to do with that. But meanwhile, if you do it at home, it works. Yeah, the joys of life. Is that related to gravity? Well, in a sense, you're modulating gravity waves, essentially. That's what they say of that because, okay, let me think now. The different terminologies, right? There's the torsion fields and there's the scalar fields. The two are related, but a little bit different. And there's also the spin fields. So the spin of time, the curve of time, and the curl of time, the curve, the curl, and the spin. So you got a lot of mechanisms here. I've got it all written down in the Maxwell Wiki. A lot of that stuff, is off my mind without the documents in front of me is a little hazy, but generally speaking, I get it pretty good. Fun stuff. It's all actually in the original Maxwell equations, all these interactions. Talks about the magnetic static fields, how you could technically manipulate that if you knew how, the same way we do with the electric fields. And people don't look at static potentials, and it's a very real thing. Tom Bearden explains it well with his steady state dynamic flow waterfall. It's a really good way to visualize what's going on here with the holes coming out of the Dirac Sea, popping in a new droplet in the waterfall. Seems static from far away, but as they get together, it's a whole freaking ferocious, energetic, always moving system. I think that's the better way of explaining it all. So the thing is, I think I go too long in my live session. The last one was like an hour, and I don't want to get people, to sleep with all this stuff. So I just actually wanted to come on just for an update. And I was proud to announce that past 3 weeks, many of my cells are still working great. So I'm optimistic with that. And that's what got me to say, well, I'm going to start working on the next phase now, which is the controlling and switching mechanisms for these cells. So once I get that going, I'm probably going to use the SCRs because it's the most quote unquote analog way of doing it. Don't need to waste additional switching current. It'll self trigger itself at the right threshold. Then I want to send that back to the front bus and possibly, I guess I'll have to build an isolation coil at some point if this works the way I want it to tap off the extra, charge a battery or something. Why not, right? If we can convert that to higher potential and the cells can re-engage to make up for the loss of that pulse from the next cycle, I mean, yeah, I mean, it's just a no-brainer, really. But I still want to build my Zamboni pile with my electrodes and my piezo capacitors, more like John Hutchinson did. Maybe with the addition of if I can figure out how to make these solid state electrolytes thinner, a combination of everything, I think it would be very interesting. And I already know how I'm going to feedback it, and that's basically a joke. But then that'd be interesting because just like John, right? You can just give it a tap, and the whole thing self starts the reaction from the piezo pulse, and then it goes on and on like that. So that's something for if one day I get my garage or something. But I've got all the data, all the info. So you take it one step at a time, right? So that's what I've been doing, and I just wanted to say hello to everyone, and that it's all going. Maybe not at the speed I wanted to, but it's all going, and everything is positive. And I guess I will say goodbye for tonight because I'm trying to cut this short here. I don't want to go 1 hour because people end up not watching. So what's the point of just rambling on and on to myself here? So I will say goodbye to everyone, and good evening, good day, good morning, whatever you happen to be. And I will keep you posted, and I will keep uploading the videos that are worthwhile, and the explanations and the theory and the demonstrations as I go along here. And with that said, have everyone a great rest of your time. Thank you very much, everyone.